Now, recently, I wondered. Let we know that a year has 365 days, right? And this is fixed. A year contains 365 days. And I just wondered if this number was different than 365. Let's say it was 366 or 367. Is there a way that two people had the same birthday? And it turns out, yes. And this is just some elementary number theory concept actually. We can solve it with number theory. So let's say you were born in X and another person was born in Y. How do we determine X and Y? Basically, you take 365, which is a year, how many days are in a year. Then you multiply this with the year that you're in. We are in 2025, so we multiply this by 2025 to get how many years have passed since zero, the beginning that we set our calendars. And then you add some C, which marks the current day, or we can actually detail this number, oops, by saying like we are in the 12th month, we are in December, so we can say 20 multiplied by a month contains 30 days, so 30 plus we are in 23rd day, so 23. So this gives us the I don't know what to call it, but this is basically the day you were born since zero, right? So let's set X to be a person's birthday based on this summation, and Y to be another person's birthday. Now, let's say we set the amount of years to be M rather than 365. So if M was 10, then a year would contain 10 days, right? We would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Now, we want both of these people to have the same birthday, right? So what we can do is we can write this simple number theory expression, which basically states that when you divide x by m, it will be equals to y divided by m, but we are taking the remainder. Sorry. When you divide x by m, you take the remainder. It's gonna be equals to y divided by m when you take the remainder. Yeah, this is the correct explanation. This basically will correspond. Yeah, this will work basically. And then what you can do is, well, using this expression, we can write m divides, so x minus y, right? So this is, I think, kind of obvious. If they both give the same remainder when divided by m, then we can just subtract both of them, and m will divide both. And we should note that x is bigger than or equals to y. Yep. Actually, this is kind of trivial, but I just wanted to state that x is bigger than y. Yep. So we can easily see that the biggest m is equals to x minus y, right? This is the biggest m. So if somebody was born in like, oh, I don't want to 2000, right? Not the year, just the day from zero, the way we calculate it using here. And if other person was born in 1000, then if we set the yearly calendar to be 1000 instead of 365, then both of these people will have the same birthday. Interesting, right? And to further improve our model, what we can do is we can work on 3 dates. For example, x is congruent to y, which is congruent to z. Actually, let's put z like this. Mod m. If we had 3 people, then what? Then we can say, similarly to what we did before, we can say m divides x minus y, m divides z minus y. So we are looking for m, right? So what we can do is we can take the greatest common divisor of these two values, right? So we can take GCD of x minus y and z minus y, which will give us our answer. And we can also say from here, we can improve this. Actually, this is not an improvement. This is just rewriting the same thing with different expression. We can also say x minus z or z minus y. It's the same thing. Yeah, basically, if you had three people and if you want three of them to have the same date, then you can find the biggest m for which this is satisfied using the GCD function. And for four people, you are going to do the same. You are going to subtract x minus y minus c, z minus n, and you are going to take GCD of three of those values and realize that if both people are born in relatively prime numbers, so if you were born in 11 and your friend was born in 17, then the only way that you got both guys would have the same birthday is that if a year contained just one day, right? Yeah. So that's all for this video. I just wanted to share this because it's kind of interesting topic. And in the next video, I'm planning on exploring the physics behind credit cards, like how the transaction goes, like when you take your credit card and let's say you get a device, and when you bring that credit card to closer to the device, how does the device know how much money to take from that credit card? How does it read your ID credentials from that credit card? In the next video, I'm planning on exploring that, explaining it. So be sure to check that out. And that's all for this video. Have a great day.